Hi everyone, I'm Charlie Chu. On behalf of David Liu, Ishan Calkert, and Vanessa Lobo of Team 4, I'm excited to present Event Map. We're all part of communities, but we found that discovering and managing local events is often a complete mess. We built this platform to fix that. We've all been there. You try to find an event, but the listings are stale or irrelevant. Or you try to host an event and you're stuck managing a dozen different spreadsheets and chat threads. Location data is often wrong, and approvals are chaotic. We built Event Map to deliver three things: reliable verified locations, granular control over who can join, and a single unified platform for management. Our target users are people who need to get things done without a lot of overhead. Think students, small community groups, and local organizers. They need fast discovery, trustworthy addresses, and simple moderation. This isn't a complex enterprise tool. We intentionally kept the experience focused, approachable, and frictionless. Our solution is an all in one event platform. For users, we offer smart, reliable search with various filters for distance, category, city, and etc. For creators, we use Google's location service to validate every address in real time. And for hosts, we provide flexible event controls, letting them choose whether they want this event to be an approval required one. To make discovery powerful, we built a flexible filtering system. Users can immediately browse by category, city, zip code, and more. But the real power comes from our Google Map integration. Every event location is verified, which means when you search for events within 5 miles, you get accurate, trustworthy results every time, not just a list of random zip codes. A core part of joining an event is trusting its location. We integrated the Google Maps API directly into the platform. This isn't just a static image, it's a dynamic system. It powers our location verification during the creation and provides users with accurate, interactive maps so they can confidently find their way to the event. For organizers, management is simple and secure. We implemented an approval based system for event participation. This means hosts have the final say on who attends. Our database design ensures that every joint request is handled cleanly, preventing duplicates and ensuring an organizer only has to approve someone once. This gives them full control without the headache. Now let's look under the hood. Our tech stack is built on the foundation of Ruby on Rails and a PostgreSQL database. For authentication, we integrated Google OAuth 2.0 for secure, simple sign-on. All our calls to the Google Maps API are wrapped in dedicated helper services, which keeps our code clean. Finally, the entire application is designed to be deployed on Heroku, making our path from development to production incredibly straightforward. This diagram shows our classic model view controller architecture. The user interacts with the views via the HTML, which sends a request flows to Rails controllers. The controllers process user input, invoke the appropriate models, and return rendered responses to the views. Our models contains the core business logic and handle all database communication with PostgreSQL. We use external services like Google OAuth for sign-in and Google Maps API for address lookups and validation. Our database schema has 7 main tables. The user table stores information about login users. The events table represents all the events that are created by the user. Each event have a detailed geocoded location that is defined by the location table. To handle participation of a user in an event, we have the event participation table that joins a user ID and an event ID with the status of their participation, that is, join or left. To handle the event join request approval flow, we create a separate table event join request that associates a user ID with an event ID and records the status of the join request. Here we have 4 possible states. The first one is approval, to approve the request. The second is reject, to reject the request. The third one is pending, a request that has not been actioned upon. That is canceled, an event join request that has been canceled by the user. We have an organization table that stores information about all organizations. The creator of the organization is by default the administrator. To manage organization members, we have the organization users table that associates a user ID with an organization ID. Each event can also be associated with an organization. If required, a key design principle is to use join tables such as event participations, event join requests, and organization users to represent many-to-many relationships cleanly. We also use unique index to prevent duplicate joins. Our design process started with these lo-fi mockups. We focus on validating the 3 most important user flows: browsing events, creating an event, and managing join requests. By sorting out the information architecture this early, we were able to focus our later efforts on visual hierarchy and building a consistent UI rather than having to rework the core navigation. And here you can see those mockups translated into our final interface. We built the front end using standard Rails ERB templates with CSS, focusing on a clean, consistent design. The final product brings all our features together. Event detail pages show the Google verified addresses, participation actions, and status badges, while organization pages provide the admin tools and member roster for hosts. These projects rely on several key external APIs. Google OAuth 2.0 handles our secure sign-in. The Google Maps API is the heart of our location services, handling both address validation and geocoding for distance search. We also use AI tools to accelerate our development for tasks like generating diagrams and looking up error logs. Next, I'm going to talk about several technical challenges during development. First, we had to debug SSL certificate errors on Mac OS. Unlike Linux, Mac OS doesn't provide a bundle CA certificate file that OpenSSL can use out of the box, which caused HTTP's requests to fail until we manually configure the certificate path. Next, we ran into release phase issue on Heroku. We discovered that Heroku only executes the command in the defined release block, meaning our earlier migration and seed commands were ignored. The proper solution was to place all necessary commands inside a single script or chain them together in one release line so they exec sequentially. Finally, we exceeded Google Maps API rate limits because our test codes made real API calls. We learned that for CI pipelines and frequent pushes, we should rely on mockup API requests to avoid unnecessary network calls and stay within the quota limits. For the future, this project can serve as a strong foundation, and we're excited about the next steps. We plan to build a full invitation systems, add event recommendations based on a user's preferences, and implement a notification system for reminders. These features will move Event Map from a simple management tool to a truly proactive and personal event coordinator.